Hello and welcome. In this video, we're talking about central tendency, a statistical measure that attempts to determine the single value that is most typical or most representative of an entire set of scores. Put simply, we're asking to find the value that tells us what is typical when it comes to a set of scores, a distribution of scores. And so essentially, central tendency is used to summarize large sets of data. But as we'll see, we also require central tendency for most of the statistical analyses we use in statistics. So take a look at this figure 3.1 from the textbook, and you have three different distributions of scores. Now, looking at these distributions, if you were to think to yourself, what is typical? If you look at this first one, it's clear that 5 seems to be typical because that's the center of the distribution, it's the most common, and as you get away from 5, the frequencies go down. In other words, fewer and fewer scores exist as you get further away from that value of 5. On the other hand, this second distribution, clearly what is typical is a higher score, and somewhere closer to 7 or 8. And then finally, in this third distribution, there's sort of two more common values, 2 and 8. There's two piles of scores. So what's important to note here is that these are three very different distributions, and what is typical is different in all three of them. However, what's interesting to note is that the average, the arithmetic average, is 5 for each one of these. So if you were to saying, what's the average value for A, B, and C? It's 5. But really, A is the only distribution where 5 tells you, the correct story in terms of what is typical, because that's where the actual pile of scores is centered around. But let's, go to the extreme opposite of that. Distribution C, there's not even a single value that is 5. So the fact that the average is 5 simply comes from the fact that there's just as many scores down here as there are up here, and in the middle is where you get the average after calculating it through these values. But really, 5 is not typical at all when it comes to this distribution. And the same thing with B. So what we do in Chapter 3 is we focus on 3 measures of central tendency, and the average, or the mean, is only one of them. Because as we'll see, there are strengths and weaknesses associated with each one of these measures of central tendency. So this video, what we're going to cover is how to calculate each one of these, along with the advantages and disadvantages of each from a statistical standpoint. All right, so we're going to start with the mean. And the definition of the mean is the arithmetic average. So we use means in our daily life all the time. Let's say it takes me an average of 20 minutes to get to work. I'm going to use that information to decide how early I need to leave and things like that. So whether you know it or not, you've already been using this in your life. And it's calculated by adding all of the scores in a distribution together and simply dividing by the number of scores. So this is the formula right here. This symbol right here is mu. It looks like a U, but it's actually a Greek symbol pronounced mu. And this is what we're going to use to indicate population mean. So population mean, when you have a population of scores, if you want to calculate the mean, you add them all together and divide by the number of scores. So that's what this notation is telling you to do. This symbol right here is sigma. So sigma, another Greek symbol, it tells you to add together whatever it is calling for. So in this case, it's saying sigma x. Take the sum of all of your x values and divide by n, capital N, which is population size. So how many scores are in your population? Now, this formula here is the exact same thing, except this is sample notation. So if you have a sample of scores, And again, look through the text, but a sample is a subset of the population. If you want to calculate the mean for a sample, you add up all the scores in that sample and divide by lowercase n. Lowercase n is simply sample size. So let's actually look at some numbers here. Here we have 4 x values, 4 scores, a 2, a 2, a 6, and a 10. Now let's first assume that they're a population. So this population has 4 scores, and to calculate the mean, which is mu, you add them all together and divide by the number of scores. So 2 plus 2 plus 6 plus 10 sums together as 20. That's up here, 20, divided by n, and there's 4 scores, so 20 divided by 4 is 5. The population mean is 5. Now, if you treated this like a sample, you would also get 5. So the calculations between a population and a sample are the exact same. We simply use different notation to indicate whether or not we're dealing with a population or a sample. So keep track of your notation, because it is really important to organize populations differently than samples, because eventually the calculations do become different. That's it though. All right, so a little more information about the mean. Statisticians like to call the mean the balance point of the distribution. And it's the balance point essentially for the following reason. So this column right here includes what are called deviation scores. A deviation score is simply how far each individual score is from the mean. So now remember, our mean was 5. So if I subtract 5 from each score, I get my deviation scores. So 2 minus 5 is -3. 2 minus 5 is -3. 6 minus 5 is 1, and 10 minus 5 is 5. So if you add up all your deviation scores, you're always going to get 0. And that's where this balance point idea comes into play. It's the idea that there's just as much deviation below the mean as there is above the mean. So all of the negatives, there's just as much negative as there is positive. And that's where you get this idea of the mean being sort of the balance point. All right, let's talk about the advantages versus the disadvantages of the mean. Now, importantly, what we're going to see is that throughout this semester, we use the mean a lot, and we rarely use the median and the mode. And the basic reason for that is inferential statistics require the mean and not the median and the mode. The mean is more informative, and that's going to become apparent later on this semester. But one of the reasons for that is the mean involves a calculation of every single score in your distribution, whereas the median and the mode do not. So the mean has more information than the other two measurements. There is a disadvantage, however, to the mean. A couple, actually. The first is that the mean is sensitive to outliers. So what's an outlier? An outlier is an extreme score, one that is very different than the rest. So here we have an outlier. The outlier is this 12 over here. 12 is clearly very different than all these scores down here. But remember, in chapter 3, central tendency, we're trying to determine a value that tells us what is typical of the entire distribution. So when I calculate the mean from these 6 scores, it calculates to 4. But what you can see, of course, is that there's not a single 4 in the actual distribution. So to say that 4 is what is typical is not all that accurate. And that's because this outlier is dragging the mean upwards, because you have to involve every score when calculating the mean. So that's a disadvantage for sure. Another disadvantage to the mean is you can't always calculate the mean depending on the scale of measurement you're using. So for example, and by the way, refer to your 4 scales of measurement: nominal, ordinal, interval, and ratio. You cannot calculate the mean for nominal or ordinal data. So nominal data, for example, college major. Let's say you have a psychology major and an English major and an anthropology major. You can't take the average of these nominal values. You can't average together psychology and anthropology. You basically have to have numerical value, but specifically interval and ratio data. So the mean is great, but you can't always calculate it, and it's sensitive to outliers. So let's talk about the median. The median is the midpoint. And so when scores are listed in chronological order, the middle value is your median. And sometimes it's referred to as the 50th percentile, which means that 50% of the scores are below the median and 50% of scores are above the median. So for example, on the SATs, if you score in the 50th percentile, that means that you scored higher than 50% of other students and 50% of students scored higher than you. That is the median. So let's look at an example. Find the median for the following 5 values. So they're already in order, they're already in chronological order, but if they weren't, you'd have to rearrange them. And then you simply find the middle value. And so here the middle value is 8. And here it is in a histogram. So what's important here, I think, is that it's clearly the middle value, but what happens if you have an even number of scores? So for example, if you had 6 scores, there would not be a direct middle value. And so simply put, what you do is you take the 2 middle values and calculate the average of those 2. So take whatever your 2 middle values are, add them together, divide by 2, that is your median. All right, let's talk about the advantages and the disadvantages of the median. The major advantage of the median is it's not sensitive to outliers. So let's look at a new example. Here we have 7 scores, and they're in order, so the median is 6. If you were to calculate the mean, you would get 6.1. So how do you do that? You add all the scores together, divide by 7, gives you 6.1. Now imagine what happens if you take this score, this 9, and turn it into an outlier. So all of the scores are exactly the same, except for that 9 becomes a 50. Clearly 50 is an extreme score. It's very different than the others. Notice how the median is not affected though, because the median only takes into account the middle value, or values if there's 2. Whereas the mean was drastically affected. It went from 6.1 to 12. And again, if we're trying to determine what is typical, sometimes the median is a more accurate representation of central tendency. All right. Actually, before we go to the mode, there is one thing to consider from the median, the disadvantage. And the disadvantage, simply put, is that you cannot use the median for many of the statistical analyses we use in this course. So the median, the reason it's problematic is that it only cares about the middle value, and it pretty much disregards everything else. And so it doesn't help us really understand the full complexities of a distribution. And this is something I suppose you'll have to take, you'll have to take my word for right now, but you will see this firsthand when you actually conduct inferential statistics later this semester. All right, so finally the mode. The mode is the easiest to calculate. The mode is simply the most frequently occurring score. So here we have this histogram of student soda preferences, and more students preferred Coke than any other brand of soda in this data, and so Coke is the mode. Coke occurs more than any other value. And that's it. So you simply look through your distribution. Whichever number or whichever category appears most is your mode. And we'll talk about some additional things to consider in a moment. But let's talk about some advantages and disadvantages. I'll come back to that slide in a moment. So the first advantage is that the mode can be used in any scale of measurement. So for example, here we have nominal data, categories, names of soda brands. You cannot calculate the mean or the median for this data. So you can't calculate the average, the mean, because you'd have to add things together and divide, and that doesn't work with categories like this. You also can't calculate the median because the median requires you to put things into an order, and nominal data does not have an order. The second great advantage of the mode is you can indicate more than one value. So here in this data, there's two modes. We call this bimodal. Bimodal, two modes. So the modes are 2 and 8. Each of them are equally likely to occur. And you can't do that with the median or the mean. The mode is the only central tendency measurement that allows you to indicate more than one value. We're going to come back to one additional piece to that in a moment, but some disadvantages to consider. Similar to the median, the mode is not as useful in statistics, and the reason is that it only takes into account one value, and it disregards the rest. So when I consider Coke to be the mode, these other values are not even considered. So, these could be other numbers, other frequencies, and as long as it's below 8, it's not going to affect my evaluation of the mode. So it doesn't take into account all of the data the way that the mean does. But I think the major advantage is you can identify more than one value. Now let's look at one additional piece to that. So here we have some data looking at the number of fish that a fisherman caught at various times of day. And what you see here is that the most fish were caught at 6 a.m. There were 12 fish caught. But we're trying to figure out what is typical. And you can see a giant pile of scores here, but another pile of scores here. This value here at 6 p.m. is only 11 fish. So it's not as high as the 12, but it's pretty clear that that's also a pretty good time of day to go fishing. So what we can indicate here is what's called the major mode and the minor mode. Think of the major mode as like first place, the absolute winner. But if you think that there's a second close value that's worth talking about, you can indicate that as the minor mode. Now this is subjective. There's no rule that says you have to do this, but it's something that you could do because as a researcher, your job is to tell the reader the story that you want to portray. And so in chapter 3, it's all about central tendency, which is what is typical, what is common, what is, we're trying to summarize the data. And the great thing about the mode is it allows you to do that by using more than one value. All right, so in summary, we have 3 measures of central tendency: the mean, the median, and the mode. Each have their advantages and their disadvantages. However, we rely significantly more on the mean in statistics, and that'll become much more apparent throughout the rest of the semester.